All right, this is the first of several videos about the reactions that occur between strong acids. Well, between acids, may they be strong or weak, and bases, they may be strong or weak. So we've really got four categories: strong acid, strong base, strong acid, weak base, weak acid, weak acid, strong base, and weak acid, weak base. So the first one here will be strong acid and strong base. And this is pretty straightforward because when they react, you get this reaction. H plus OH minus reacts to form water. And we can calculate the pH by determining the concentration of the excess reagent. So we're going to do three examples. Let's just take a look here at what we've got. All right. First one, a solution is prepared by combining 100 milliliters of 0.1 molar HCl and 100 milliliters of 0.1 molar NaOH. And our reaction right there is in red. H plus OH minus reacts to form water. And we've got a table. The table is useful because it allows us to keep track of all the moving parts. And when we get a little further into this, there's going to be quite a few moving parts. Right now, not so difficult, but it's still a useful tool, okay? So we can look at this, and right off the bat, we see we've got a monoprotic acid and a monohydroxide base. We've got the same volumes, and we've got the same concentrations. So what we have is an equimolar amount of each. So we can calculate the moles of H plus. It's molarity times volume in liters. So 0.1 molarity times 0.1 liters is 0.01 moles of H plus. And I can do the same thing for hydroxide, and I get 0.01. So I fill in the table, okay? Now, because the amounts are the same, I have neither a limiting nor an excess reagent. So I just write Na. How do I determine the pH? Well, I can calculate the final volume, but it's sort of irrelevant in this particular problem because I have equimolar amounts. So when that happens, I essentially have pure water. I have sodium chloride that's dissolved in the water, but that doesn't contribute to the change in pH. So my pH for this problem is going to be 7.00. And that means, of course, that H plus and OH minus are equivalent, and both are 1 times 10 to the minus 7th molar. This problem, this is as easy as they get. The next two, only slightly harder and not very difficult. Okay, so here we have 260 milliliters of 0.1 molar HBr and 240 milliliters of 0.1 molar KOH. HBr is on our list of strong acids. So we write an equilibrium, we write a reaction which is not an equilibrium. It is a unidirectional reaction. We get HBr plus KOH gives potassium ion and bromide ion and water. All right, and again, we have a little table that we need to fill out to keep track of what's happening. So here, moles of H plus, I have 0.1 times 0.26, and I get 0.026 moles of H plus. Okay, because since it's a strong acid, every mole of acid that I have completely dissociates into H plus. I can do the same for my strong base, and I get 0.024 moles of hydroxide. And now I do have a limiting and an excess reagent. I can see that my acid is going to be slightly in excess of my base, so that makes my acid my excess reagent, my base the limiting reagent. Now, I actually do need to calculate final volumes and final concentrations. So I add the two volumes together. I get half of a liter. I can see what my H plus concentration is because I'm going to just subtract the limiting reagent from the excess reagent, which would be 0.026 minus 0.024 gives me 0.002. Divided by my volume in liters, I get 0.004 molar H plus. That gives me a pH by the negative logarithm of the hydronium ion concentration of 2.40. Now I can get to my OH a couple of different ways. I can find the POH and then take 10 raised to that number, or I could divide my 0.04 by my kW for water by 0.004. In either case, I arrive at the same number, which is 2.5 times 10 to the minus 12th molar. And that's it for this problem, where we have the excess reagent is the acid. Now, the last part of this first video will be similar, slightly different. There's one little twist on this. We have 380 milliliters of 0.1 molar HNO3, which we recognize as a strong acid, 420 milliliters of 0.05 molar barium hydroxide, which we recognize as a strong base. But in this problem, the barium hydroxide gives 2 hydroxides for every mole, 2 moles of hydroxide for every mole of barium hydroxide. That's going to affect the way we do this problem only a little. Again, we set up our table. We look at our concentrations. We compute the number of moles of H plus is molarity times volume, and I get 0.038 moles of H plus, so I put that in the table. In the base, I'm going to have to multiply my answer by 2 because I get 2 hydroxides for every mole of barium hydroxide. So 2 times 0.05 times 0.420 gives me 0.042 moles of hydroxide. So I put that in the table, and now I can see that my excess reagent is the base. It's just the kind of the opposite of the first problem. Now let's compute our final pH. We know, or we should expect, that since our excess reagent is OH minus, that our final pH is going to be greater than 7. So I can get a final volume. I add 0.38 plus 0.42, I get 0.80 liters. I get my OH minus. That's going to be the difference between the number of moles of H plus and OH minus, which would be 0.004, divided by 0.8 gives me 0.005. And now my pH is actually derived from the POH because I've computed an OH minus concentration of 0.005 molar. I take the negative logarithm of 0.005 and I subtract that number from 14, I get 11.7. And again, I can compute H plus by taking 10 raised to the negative 11.7, or I can go via the kW route. In either case, I arrive at the same answer of 2 times 10 to the minus 12th molar. All right, so that's our 3 different scenarios for strong acid, strong base. We just look at who's in excess, and based on that amount that's in excess, we do a straightforward pH calculation. Perhaps we have to take another step of computing POH first, but we still can arrive at a pH number. All right, the next video, or perhaps several videos, will be as we start to look where one of these acids and bases is weak and the other is strong. That's probably going to take several videos, but that's okay. We'll wrap this one up here and start on the next one.